It's time to light them up and confront the enigma head on. So Sam and Dean are braced with shotguns filled with salt to temporarily stun them so we can learn more about the factors affecting free energy. With what we know about free energy so far, the salt rings have been helping out, but we needed more. So Sam and Dean have been continually firing rounds of salt at the thermodynamic entity, temporarily stopping them enough to get more information about delta G and its relationship, like the effective temperature on reaction spontaneity. We know that delta G of the system is equal to delta H in the system minus T delta S of the system. So we can look at these variables, T delta S and delta H, to understand how delta G will be affected by different factors, like temperature. So let's focus on the enthalpy value. Generally, enthalpy is going to have a more substantial impact on free energy than the entropy variable here. As we know, most exothermic reactions with their significant negative delta H value are going to proceed spontaneously. Therefore, if they're spontaneous, then the delta G is also going to be spontaneous. So when I have my delta H naught of the system, I can say that when delta H naught is less than 0 or exothermic, then delta G naught will be less than 0 and spontaneous. When it comes to entropy, the temperature of a reaction affects the magnitude of the entropy variable. So when temperature increases, we know that entropy is going to increase. And so for many reactions, overall spontaneity is contingent on this T delta S variable. So from analyzing the signs of delta H and delta S, we can predict how temperature influences delta G. And of course, in order to understand all of this, we are using standard state values. But sometimes to keep things universal, you might not see the standard state or the degree symbol here for some of our variables. Just know that it's assumed that you understand that we are at a standard state, because in order to get these values, we need to use standard conditions. We also assume that this is happening under conditions where there are no phase changes. That way, there are going to be minimal variations of our delta H and our delta S values with temperature. Using this knowledge and assumptions, we're going to examine 4 combinations of positive and negative delta H and delta S values. 2 combinations that are going to be temperature independent, and then we'll talk about 2 combinations that are temperature dependent. So this is basically all going to happen when certain reactions remain spontaneous or non-spontaneous, regardless of temperature fluctuations. Let's start with some examples where we're going to be temperature independent and spontaneous at all temperatures. So a reaction is going to be spontaneous at all temperatures when our delta H is less than 0 or exothermic and delta S is greater than 0. So what we want to do is start with our free energy change expression. And we know that we just said our delta H is negative and our delta S of the system is going to be positive. And even though our delta S of the system is positive, when we take into consideration this entire term or variable, T delta S, it's still going to be negative because of the negative in front of it here. Therefore, our delta G naught is going to be negative. Here's an example of hydrogen peroxide decomposing into water and O2. It has a delta H value of negative 196 and a delta S value of 125. As you can see, we have the parameter set. Negative delta H, positive delta S is going to give you a spontaneous or negative delta G value. You can also say that exothermic reactions with increased entropy are spontaneous across all temperatures. Next scenario that is temperature independent is when we're non-spontaneous at all temperatures. This is a scenario where our delta H is greater than 0 or endothermic and our delta S is less than 0 or negative. So I have my delta H term here as positive and my delta S as negative. As you can see, if this is negative, that means this entire portion of this term will be negative because there's a negative number or value in front of you. And for our delta H of the system, it will be positive. Overall, we're going to get a delta G that is positive or non-spontaneous. An example of an endothermic non-spontaneous reaction is going to be of ozone formation. So we're starting off with O2 and we're going to form O3. As you can see, the delta H is positive and the delta S is negative, just like our pattern that we just discussed. When this happens, the overall delta G will be non-spontaneous or positive. So we could say endothermic reactions with decreased entropy are non-spontaneous at all temperatures. Next, let's focus on temperature-dependent cases. So first, we can have reactions that become spontaneous as temperatures increase. And next, we'll talk about reactions that become spontaneous as temperatures decrease. But first, let's talk about spontaneous as temperature increases. In this scenario, if your delta H is greater than 0 and your delta S is greater than 0, meaning they're both positive and we're dealing with an endothermic process, well, guess what? You can increase temperature, and as you increase temperature, you can actually cause this overall process to become spontaneous. Essentially, this is a positive number here, and this is going to be a positive number. We're going to steadily increase and increase this temperature value, making this value way bigger. And this value has a negative in front of it. So the bigger it gets, that means our delta G is going to be more negative. And if our delta G is negative or less than 0, then we are talking about a process that is spontaneous. An example will be N2O and oxygen forming NO. As you can see, we have a delta H value that's positive and a delta S value that's positive. Using these values, scientists find that this reaction will be spontaneous at any temperature above 994 Kelvin. Now, if you go below 994 Kelvin, then this process is non-spontaneous. You can also have a situation when the reaction becomes spontaneous as the temperature decreases. And this is going to occur when you have an exothermic reaction or your delta H value is negative and you have a negative entropy value or it's less than 0. Essentially, you're going to have a negative delta H value and a negative delta S value. Now, we're going to be decreasing the temperature. So overall, this value is going to get bigger and bigger. Why is it getting bigger? It's basically getting a bigger negative number. So if we have a negative number here and a bigger negative number here, then delta G overall will be negative and therefore spontaneous. An example will be the production of iron 3 oxide, for example. That's going to have a delta H value that's negative and a delta S value that's negative. As you go ahead and decrease temperature, then you're going to end up having a spontaneous reaction. And scientists find that below 3005 Kelvin, this reaction is spontaneous. So you could also say that exothermic reactions with decreased entropy become spontaneous with decreasing temperature. And we will be learning how to calculate these temperature values so that we can figure out above or below it, will it be spontaneous or non-spontaneous? We're going to get into that soon. But for now, let's summarize these 4 effects of temperature that we saw based on delta G in this table here. So if you have a negative enthalpy and a positive entropy, then your T delta S value will also be negative, causing delta G to be negative and spontaneous. If you have a positive H and a negative S, then your T delta S value will be positive, causing delta G to be positive and non-spontaneous. If both values are positive, then your delta G is going to be spontaneous at higher temperatures and non-spontaneous at lower temperatures. And the temperature that we're going to focus on that's going to tell us that is what we'll get into next. And of course, if your H and S values are both negative, again, your delta G is going to be based on temperature, so it's going to be spontaneous at a lower temperature and non-spontaneous at a higher temperature. Again, that particular temperature that's going to be below or above that is what we're going to get into next. So this table is very useful when it comes to memorizing things for your flashcard moments, right? And this is surely enough information to move forward with a powerful weapon. Let's get to Dad's card for some examples to put this all together, folks.